Alright, response video to Holiday again. Just him. It really doesn't matter. I mean, there's not too many people interested in this subject or interested enough in dealing with the arguments I'm making at all. So, even Holiday. So anyway, so he spent the whole video just whining, okay, about me being butthurt, which is laughable, right? You're the one whining, asshole. I spent 95% of my video making arguments about quantum mechanics. You spent 95% of your video whining about whining. It's just bullshit. Make a counter argument, or fuck this nonsense. I'm not the one who has to worry about the scratches or the itches or the irritations. I'm not the one that can't take a punch. Okay, you want to call me an asshole or a fucktard? Go the fuck ahead, jackass, and I'll just give you back what you deserve. Your video was insulting my intelligence, okay, as if I'm arguing from intuition, like I'm arguing something simple and the scientists have to explain it to me. No, it's exactly the opposite. People are sitting there drawing conclusions like idiots watching a magician and saying, look, he made a car appear. And they're going with their intuition instead of saying, why did the car appear? Oh, did it go through 2 slits at once? Does it magically read our minds? I mean, come on. Quantum mechanics, as understood by most of the people, is nonsense. They're not understanding what it means, what it represents. They don't understand the word probability. They don't understand that the wave function is entirely just a function of probability that has nothing to do with some kind of actual wave or some sort of actual thing in reality, that has to do with a circumstance created by interaction with photons or electrons and matter, okay, other electrons, okay. All of this is look, I played the Feynman clip. Argue with fucking Feynman. He said it pretty explicitly, okay. The photons aren't doing shit. The matter's doing all the shit. I know he said contrary things in other videos, but he's always saying those in the context of, to make it easier to understand quantum mechanics, the math. It's easier just to ignore causes and just deal with effects. But obviously, if you're going to explain what's happening, causes matter. And when he does that, he explains that it's interaction that creates these changes in momentum. So anyway, so the whole premises of quantum mechanics, the whole idea of this wave duality, particle-wave duality, was just created by the fact that en mass, in mass, just like water molecules in mass can carry waves, so can photons in mass carry waves. There's nothing mysterious in that. Information can be carried on a pool of photons, changing their density. Duh. Okay, there's nothing magical in that. Radio waves look like that, right? These low intensity photons, and there's zillions of them that make this wave front, but it's not really a wave to from the photon's perspective. The photon is not acting wave-like. Okay, it's in a group like a school of fish. Right? One fish isn't a wave. One fish isn't a school. So that's where this all falls apart, is people aren't making distinctions between how things change when you're talking about a volume of photons versus a single photon, and more explicitly, like I said, the wave function is in the matter. It isn't in the photons. And there's so many ways that I think that it's made obvious. And so I'm going to go through a couple of other elements of this argument. But yes, yes. I mean, I really shouldn't have to waste my time arguing that, yes, I'm challenging any physicist whose premise is photons actually go through 2 slits, or any physicist who believe photons carry all this information, or photons can read minds, or photons can tell whether tape machine's running. Yes, any physicist who believes that, I'm challenging their integrity as physicists. Okay, their knowledge is crap. Their understanding is shit. I'm saying they have the wrong model. Yeah. And I'm in the company of, the dead Einstein, who likewise thought all this crap was crap. Anyway, so I did write down a couple of things I just want to get to, but I think the important one is this, to just start over and try to understand, what's the mechanics of things. And I'm just saying it's quite obvious that the thing that's not being, the thing that physicists, when they're explaining quantum mechanics, that they're underappreciating or under-explaining, is that matter is not matter. That matter is made up of atoms, and that atoms are moving. Okay, Feynman talks about it a lot. He uses the word jiggling. He's always talking about it jiggling. He talks about the photon hitting the electron, and the electron jiggles it and changes its momentum. That's a pretty explicit statement. He's pretty much saying that's what happens. That's right. The action, the wave action, isn't in the photons, it's in the machinery. So if I was to do this again, even a single slit, doesn't matter. But if I have material and we have something going through, the point being made here is that the thing going through is just a bystander. And what's really happening is the action of these materials are vibrating, and their vibration is what's creating vibration or change, probability outcome here. So the fact that this momentum is being changed is changed in its momentum, in its direction, by the wave action of this material, by the movement of it. And we could, okay, this isn't, I'm not making a claim that this is how it works. I'm just making a claim that this illustrates how you could understand it, okay, how you go from an analog signal to a digital signal. And that's basically what we're talking about when they're talking about these appearance of an interference pattern. We're just talking about a digital signal, and that you could create a digital signal a lot of different ways. And one way of understanding what's happening with atoms is to understand that they might be at very different positions. Like, you could imagine matter looking like this, but what if it was constantly, every position was constantly moving, which means it could be, in any kind of place. Okay, like say a position. So it could be at a high position. These could be almost digitally based on orbits of electrons in the atoms themselves, what position the orbit of the electron is in. But you could understand that if every Planck constant of time, if this plunger, let's say, this plunger was moving to different positions. So at one point it would be, so a better way to just maybe make it blocks, then it's easier to see. So at any one time, this could be the signature. The next moment of time, the signature is like this. So you could understand that if a ball, a discrete item, was coming at this target at exactly the same trajectory at two different moments in time, at this moment in time it would miss this first notch and hit this second notch in its middle. At this moment of time, the first notch is high enough it would hit the first notch. Okay, so now you can understand how trajectories would be very different based on what position the atoms or the electrons of the atoms are in. So there's nothing mysterious, in understanding why there's different positions, and that those positions are dictated by, some sort of standard function of atoms. Like the fact that they do have probably very cyclical behavior. They rotate, they spin, they vibrate. As I was pointing out, they eat space throughout their existence. They move. The electrons are pulling, creating tension in the atoms at all times. One part of the atom is moving in this direction, one part's moving in this direction, and it ends up having a net direction. But the whole point that I'm making here is that there's this action, there's this wave action in the molecular structure that this this thing is going to be interacting with, and depending on that wave action, it's going to hit different points. It might hit this, like I said, the same position 2 different times in space won't be the same position. It won't be the same interaction. The interaction will be changed because the atoms will be in a different position. The electrons will be in a different position. So you can't hit the same spot on the surface twice in a row. Every hit is going to have this signature written on it. Now, again, and as if we understand that there's cycles, and set frequencies of vibration, then you can understand why this signal comes out digital. That there would be a pattern where this lump would be out, every 15 Planck constants or whatever it could be of time. This is going to peak, and then it's going to go back down, then it's going to peak, and then it's going to go back down. So you could think about this like a washing machine. I mean, a washing machine agitates the water, and it creates little peaks of water that pop up, and they have a cycle to them. They have a pattern to them. They're not just chaotic. They end up having a pattern, like an eddy in a stream has a pattern. And there's a pattern built out of these interactions. So now, some people on the video have posted some phaser crap one-slit experiment, now arguing that, so they have a one-slit experiment that demonstrates an interference pattern, and they're arguing that this proves now quantum mechanics, and it's just hilarious because it's like they just keep changing the rules here. So yeah, this is what they have this experiment that creates the pattern with a single slit, and they're arguing that somehow this demonstrates that because this interference pattern is different than the basic one, the historical one, that it's this one interferes with the other one. But what they're not accounting for is when they're changing the separation. This is kind of interesting. Look how much this is. This is a single slit now, and depending on how wide the slit is, this pattern gets lesser and lesser in terms of its. I'll play the video. So I think it's relatively short. You can see now as they make the slit wider and wider, they start to lose the periphery, and it flattens out. So anyway, so they're claiming that this somehow demonstrates something because because see, it's different than the Young classic two-slit diagram, and obviously it wasn't that different when they had the slit more narrow. But regardless, what they're not accounting for, again, is the fact that the pattern of the photons in the two-slit experiment, or electrons, has this kind of shape to it. Okay, in terms of the density on the two sides of the slit. So if you just take away the fact that the ones that hit the slit are killed, you see the focus is in the center, and so that this is your density. This is what you have to duplicate in the single slit experiment. So if they did this experiment by having a single slit and focusing the light here, okay, so that you would duplicate this pattern of density, the most photons being coming through this area of the of the slit, based on the fact that it's coming in this way. But I'm just trying to give an example that it essentially creates a lens, and so that's another way of looking at it, because of the fact that you've split the density here. So this is what you're talking about, is that only this part of the light focus is going to get through the slit. That they would probably get even more dramatic a pattern. It just, intuitively you can say that. So if you want to do something based on intuition, but I'm just saying you don't need the experiment to say that makes logical sense. So all of this math doesn't mean too much because they're not accounting for the fact that the focus has to be off center to duplicate the two-slit experiment and end up creating the right and the left hand side. So obviously if you took this pattern, well, let's go back to the video page. Let's take the most extreme pattern, at this, this pattern, okay, and duplicate that having a right and left side, based on what I just said. Change the focus, you'll end up with this pattern going to the left, being weighted to the left, and then do it on the right side, weighted to the right side, and then combine those two images, and you'll end up with something that's going to look very much like this. Yeah, so what else did I want to get to? There's some other point I wanted to make. But I mean, I think this is fundamentally important. Alright, yeah, you keep talking about electrons because they're bigger, but they're just as reactive. They're even more reactive, you could argue. They're even more bendable in their momentum than photons. Electrons can be deviated in their momentum very easily. So, I mean, obviously televisions have depended on that for, 100 years. Well, whatever, 30, 70, whatever, 60 years, whatever it is. I don't know how long cathode tubes are around. But anyway, it's been a long time. And we can understand... Why did I cut this out? Well, anyway, I'm just drawing the back. So, I mean, with electrons, you're still interacting. Two electrons will interact with each other in terms of usually be repulsed by each other. But regardless, the point is they're going to be just as reactive, and they're, Feynman would tell you there's just a whole lot of math about two electrons, because what happens with the electrons is they exchange photons. So as two electrons become associated to each other, what happens is photons are exchanged between them, are liberated based on how, just depending on how aggressive their rubbing is. So again, momentum is going to be completely changed. The direction is going to be completely deviated based on interfluences and exchanges between electrons. And that's quantum mechanics. And so let's understand too that Feynman, when he was doing these lectures in 1970, this was called quantum electrodynamics. Okay, it wasn't called quantum mechanics. It was called quantum electrodynamics. For a good reason, because this is about electrons. This isn't about photons, and it's not even about electrons moving. It's about what happens when electrons interact with anything that's interactable with them. They're charged, they interact with things, they consume and produce photons. So there's just they're obviously going to influence anything atomic. They're going to influence an atom, they're going to influence a photon, and they're going to influence an electron. Any one of those things moving by electrical charge created by electrons is going to be changed, and you can see dramatic effects. You can make whole pieces of matter, a piece of paper, because it has a static charge on it. I can make it stick to something. It will fly over to it. It'll cross an inch of distance to fly over because of an electron. So let's not underestimate. Let's not pretend that because electrons are bigger, they're less influenceable, because that's just wrong. All right. Anything else? Alright, so the final argument I would make is that the definitive proof for all of this could be done with an experiment that just duplicates the pattern that comes into the two-slit experiment. So if we could do the two-slit experiment, and the only fact we'd need to do is have the target distance the same, just everything the same as they're getting their interference. So create a perfect interference pattern, and then redo the experiment, and this time aiming the gun. Alright, create an aiming mechanism so you can aim and be assured with a 99% efficiency of creating a photon that can be aimed precisely enough to, let's say, I mean, obviously you have to still be able to duplicate the pattern. So let's just pretend this two, well, let's draw it just bigger, I guess, and then we could argue what the pattern is. So here's the two slits, and I'm saying the focus now, the pattern of photons that are coming into the two slit experiment have a density like that, you know, a pattern of density. So a good percentage of most of the photons would end up hitting the slit, and the periphery go by it. Now, if you duplicate that by aiming, okay, you can be assured that you create an aiming device that can duplicate this pattern, okay, with enough precision that it could duplicate the pattern, let's say, or approximate it. I'm just saying that it has to approximate the pattern. If it shoots the same photon in the same place every time, obviously you're not going to get any two slit interference pattern. You're not going to get any pattern because you're shooting it in the same exact place. So it obviously has to create a, like, you know, it went through this side, you just don't know exactly where it went through this side. Or you have to be precise enough to say, okay, first shoot it here, first shoot it here, you know, where you fill the whole area, obviously for both sides. And so that, well, anyway, the point is that the key point here is that you have the information of what slit it went through. I'm saying you'll get exactly the same interference pattern. So you'll have the interference pattern, you'll have knowledge of what slit it went through, and you'll have that knowledge because you merely did it with aiming. You didn't have to acquire information of its momentum and its position to gain information about what slit it went through. So you didn't have to interfere with it to understand where it is. You knew where it's going. And knowing where it's going is you're getting the information without interfering with it, is the point. So there's no collapsing anything nonsense. Which is still nonsense. Again, I'm still going to argue you cannot see a photon or an electron. There's no way to see one passively. I mean, can I say that as clearly as possible? You cannot see one passively. Even when they put atoms below glass, and even Feynman says this in his video, okay? He says you've changed the experiment. As soon as you put that little detector atom on the glass, you've changed the experiment. So he's admitting the experiment is changed based on that change in the circumstances, and that's why the percentage goes back to 4% instead of 16 and 0 being the range, the average of the glass reflection. It's because you've broken the experiment. It's no longer an experiment about glass. It's an experiment about interaction with an atom you placed on the bottom of the glass. So again, there's no way to passively observe an electron or a photon. You can't do it. You can only aim them. That's the only way you can have knowledge of where they're going, is to aim them, is to know ahead of time where they're going to end up. Okay. So let's see. Anything else? Yeah, I think this explains it. Okay, this vibration of the matter explains it. This explains why there's a signal. The signal's being created by the machinery. See, that's another point that, I said twice, I used the metaphor in my video of a pinball machine. Okay, the machine creates the effects on the ball. The ball doesn't do anything. The ball is reacting to the machine. And and then you show me a stupid clip of bowling that I'd already told you the video sucked. But whatever, I won't get into that. So yeah. So yeah, I could care less about your bullshit about you don't like me saying fuck you when you insult my intelligence. And you insult my intelligence when you accuse me of seeking an intuitively correct answer. Fuck you. And then you at the end of your video you're talking about some kind of fear or something. I mean, I started just shutting my brain off by the end of your video, but yes, this is a waste of my time. I don't give a fuck whether you like or dislike me. I don't give a fuck whether you any of this shit. You want to play these psychological games? You play them someplace else, jackass. But you make a video insulting me, and I'm supposed to say thank you, okay? Look at you sit there and say, oh, in my video I did talk about what you said. No, you didn't. You sit there and said, well, inmendham says the photon does some little thing here, does whatevering. And that's your paraphrase. Yeah, it was a pile of shit. So yeah, why should I say thank you to that? It was a lousy paraphrase of what Inmendham said in his video. Again, you ignored what I said in the video. I can replay it again. You want me to replay the Feynman clip, for fuck's sakes? It's only, what, 2 minutes? You want me to play it over and over and over and over and over again and keep re-explaining to you what the fuck he's saying there quite clearly and explicitly? Shit. Anyway. So enough. Till next time. The 2 slit is dead. Yeah, it's just dead as a... Again, quantum electrodynamics. That's the subject. Quantum mechanics, the magical photon story, is a lie. Quantum electrodynamics is what's happening in reality. It doesn't